Today's session in JS Networks is about array implementation of queue. Last class we have seen array implementation of stack. So now let us go for implementation of queue through array. First we have to know what is a queue. Queue is defined as a linear data structure that is open at both ends. The operation in queue are performed in FIFO, that is first in, first out. Just imagine a normal queue. So how we are entering into the queue? We are entering through the back side, right? And we are exiting from the queue through the front side. So who is first entering into the queue? He is the first person who is exiting, right? So that is why it is performing in the principle first in, first out. This is the principle of queue, FIFO. So this is a queue. DQ is deletion of an element and NQ is a term for insertion of an element. Two main points are here, front and rear. That is, front shows points to the first element and rear points to the last element. A queue is like a line waiting to purchase tickets. The position of entry in a queue ready to be served, that is the first entry that will be removed from the queue, is called the front of the queue. That is the element which is to be removed. He will be in the front, right? So that is what front of the queue or head of the queue. The position of the last entry in the queue. This is the last entry and that is rear end. Front is the item which is next to be removed. That is, he is in the front of the queue. So he is that element is a member who is going to exit if deletion is happening. Okay. And entering, that is adding an element into the queue, is done through the rear end or the tail of the queue. Removing the term is DQ and adding the term is NQ. To implement a queue using an array. So these are the steps. Create an array of size n. Two variables, front and rear, both of which will be initiated to 0, which means the queue is currently empty. That is, front is equal to rear is equal to 0. And that shows the queue is empty. Rear is the index up to which the elements are stored in the array, the back end. The last element which is inserted into the array, that is rear. Front is the index of the first element of the array. You know, in array we are giving importance to the term index. Index shows the position of the element. Okay, and for an array, index always starts from 0. Implementations of queue operations are as follows. We have already discussed NQ, that is addition of an element. If rear less than n, that is the back side, right? Back end of the queue, where we are entering the item, entering the element, that is a rear side. And if the rear is less than n, that means it is not full. The queue is not full and space is there so that more members can be added. If rear is less than n, which indicates that the array is not full, then store the element at ARR rear. ARR is the name of the array and rear is the last point where the element is going to insert, and increment the rear by 1, because suppose this is the last point of the queue and this was the rear point. Okay, so when we are adding one more element, so rear will be shifted from this position to this position, because this area or this point the element has been added, this index. Okay, so an increment rare by 1, but if rare is equal to n, then it is said to be an overflow condition. That is, rare is equal to n, that is no spaces there, and the condition is overflow. That is, no spaces there for adding one more element. So that is about NQ. Next is DQ. DQ is removal of an element from the queue. If rare is greater than 0, that means at least an element is there in the queue, because rare is greater than 0. 0 is the first index, right? So it is greater than 0. That means a space is, element is there which can be deleted. If no element is there, it shows underflow. The element at the ARR front can be deleted, but all the remaining elements have to shift to the left by one position in order for the DQ operation to delete the second element from the left on another DQ operation. DQ operation is deletion of element, and when an element is being, suppose this is an array, okay, and when this W we are removing, what happened? This H will come here, E will come to the position of H, N will come to the position of E. This is what in a queue happening. Same way, same procedure for this queue also. Okay. That is, ARR of front can be deleted from all the remaining elements, and all the remaining elements have to shift to the left by one position in order for the DQ operation to delete the next element. Because the second person will come and stand at the first position, and that is an item which is to be deleted in the next DQ operation. Front. Get the front element from the queue ARR of front if the queue is not empty. That is, you are going to delete the element. And if element is there, the element which is at the front end of the queue is the one which is to be deleted. That is ARR of front. ARR is the name of the array. And next point is display. Display, you know, print all the elements of the queue. If the queue is non-empty, traverse and print all the elements from the index front to rear. You have to travel through each and every element if it is non-empty. Some elements are there means from the starting. From the starting you have to travel and you are going to print it. Then it will go to the next one. It will be printed, and like that the full elements will be displayed. Okay. Now, array representation of queue. Queue can be represented by using linear arrays. Sequential elements. Elements are arranged one after another. That is an array. So, queue can also be represented by using linear arrays. Two variables, front and rear. Front and rear variables point to the position from where insertions and deletions are performed in the queue. Initially, the value of front and rear is -1, which represents an empty queue. The value of the front and the rear will be -1, and it shows that the queue is empty. This we have to keep in mind. Okay, front is equal to rear is equal to -1. That means the queue is empty, underflow condition. Array representation of a queue containing 5 elements along with the respective values of front and rear. This is an example. India, that is the data, and at the 0th index INDIA. Okay, so I is at the front point and A is at the rear point. The above figure shows a queue of characters forming the English word India. Since no deletion is performed in the queue till now, therefore the value of front remains -1. So if nothing has been deleted, that means front is -1. That is what you have to keep in mind. If front is equal to rear is equal to -1 means it is empty, and In this point you have not deleted a single element, okay? So front remains -1. However, the value of rear increases by 1 every time an insertion is performed in the queue. When you are adding an element, rear will be shifted. See here, the element G is being inserted, front no change and rear has been shifted to this point. Now, algorithm to insert any element in the queue. That is, from the rear side, we are adding the element, inserting the element. Step 1. If rear is equal to max minus 1, that is max is n, maximum number of elements, okay. Since it is starting from 0, index is always starting from 0 and it will go up to n minus 1, okay. So, if rear is equal to max minus 1, that means no spaces there for inserting element. Now next, step 2. If front is equal to -1 and rear is equal to -1, that is no element is there at that situation, okay. Now you are going to insert the element and at that time front and rear will become 0, will point to 0 because nothing is there. The condition is front and rear is -1, that is no element is there. Now the element which you are going to insert, that is the first element, okay. At that time front is equal to rear is equal to 0. Else, if already elements are there, that means rear will become rear plus 1, okay. And then step 3, set q of rear is equal to number at the last point. That is, at the rear end of the queue, you have inserted the new number. And step 4 is exit. So that is algorithm. This is a C function, void insert, int q, int max, int front, rear and item, which you are going to insert. If rear plus 1 is equal to max, print overflow, no spaces there, else front is equal to -1 and, that is logical, and rear is equal to -1, that is front is equal to rear is equal to -1. Set front as 0 and rear as 0, else rear will be incremented and the item is inserted to the last, inserted as the last element of the queue, okay. So this is the C function. Now, you are going to delete an item. After deleting an element, the value of front will increase. See, now this element, here we were having I and I is deleted. Now the front has moved to n. Rear, no change. Algorithm to delete an element from the queue. If front is equal to -1 or front greater than rear, that is underflow, no element. Front is equal to -1 and front greater than rear, that means underflow, that is nothing is there to delete. Else, set val is equal to, that is value is equal to q of front, front is equal to front plus 1, okay. That is the element which was at the starting, that is stored in the term val, value, and then front is shifted to front plus 1. That is, in the example I we have deleted, right. So this is I and I is stored in val and then front is shifted to 1. Front, it was 0 and 0 plus 1 is 1. So that is about the algorithm. This is a C function for deletion. Y is a variable where you are storing the deleted element. If front is equal to -1 or front greater than rear, the condition is underflow, that is no element is there to delete. Else, again you are checking if front is equal to rear, both are same, okay, only one element is there and that element is deleted and front and rear will become minus 1, else front will become front plus 1, and the element which is deleted, that will be stored in y. Okay, and that y is returned. That element, the front element which you have removed, that is now returned. Okay, so this is the C function for dq. So that is about array implementation of Q. Q is following the principle FIFO, first in first out. Okay, NQ is adding the element from the rear end, DQ is deleting the element from the front end. This is a very important question in data structure. Hope it is clear for you. Thank you.